Hi everyone. Yeah, I'm just recording for Brian. One of the problems that we were looking at just the other day, which was use the Taylor expansion to express ln, yeah, 3 plus x. Yeah, use a Taylor expansion in series in as a series in x, as a series in x. And I suppose that also means powers of x, really, doesn't it? Yep, we need to express it in powers of x. So, really, in this particular question, we don't really need to use a Taylor series. Of course, you can use any series at all uh, to do that. I could use a Maclaurin series, and in this case, if I use a Maclaurin series, of course, straight away I'm going to get a series that will be in powers of x. I won't have to do very much. In other words, what I could do is I could, I'll let f of x, I'll let g of x equal to ln 3 plus x. Now in this case, I think it says, what do we have to do? We have to go as far as the x to the power cube term. So what I could do is go, here we go, g of 0 in this case gives me ln 3, yeah, and then I've got g dash x will be 3 plus x to the power of minus 1. So g dash 0 will be 1/3. G double dash x will equal minus 1, 3 plus x to the minus 2. So g dash 0 in this case will be minus 1 on 9. And then the next one will be g triple dash x will equal to 2 x plus, 3 plus x to the minus 3. So g triple dash 0 is going to equal to 2 on 27. Okay, so we can straight out now write out our Maclaurin series for that. Yeah, so we could have g of x, which is my Maclaurin series. Yeah, will be equal to, there's my g of 0 there, ln 3. Yep, and here's my first term, so that will be plus x divided by 3. Second one, minus x squared divided by 9, and then I've also got to multiply that by 2 factorial. Yep, so 2 factorial is going to give me 27, isn't it? Yep, and then plus, this one will be 2 on, so this will be 2x cubed on 27 times by 3 factorial, and I think that gives me x cubed on 81. So there's my series expansion. But you'll notice in a way I used the Maclaurin series there. I didn't really use a Taylor series. So how would I use a Taylor series for this? Okay, so the way I'm going to do this, to use the Taylor series, I'm going to let, I'm just trying to think here. So I'll let g of x, in this case I'll let g of x equals to ln 3 plus x. And then what I'm going to do is go g of x minus 3, which will give me ln x. Now, from the last chapter, the last video I did, I basically talked about what this is in this case, and I'll let that equal to f of x in this case. Yep. So if I'm looking at a series expansion of a Maclaurin series, x minus 3, that's really just a Taylor series. Yeah, so I'm going to find a Taylor series for ln x about, to remember, there, it's going to be about the point x equals to 3. Okay, so that will give me exactly the same thing. So, and I'll show you. So yeah, sure enough, you can use a Maclaurin series, but if you want to use a Taylor series to do that, and that's what the question asks. So this is probably the right way to do it, we'll just use ln x, and you'll see it'll be exactly the same thing. So let's do a Taylor series. So we've got f of x, so I'm using this here. So I've got f of a, in this case where that's 3. Yep, so that equals to a also there. Yep, so I've got f of 3, which is just ln 3. Good. And then my first one is f dash x, and is equal to 1 on x. And so f dash 3 is a third. The next one is f double dash x will equal to minus x to the power of minus 2, which will be f double dash 3 will equal to minus 1/9. And the triple dash, f triple dash x, will equal to 2x to the minus 3, and f triple dash 3 will give me 2 on 27, exactly like what we got. Now let's write our Taylor series. Do you remember? Our Taylor series expansion is this. Okay, here we go. F of x equals to f of a, which is ln 3, right, plus 1/3. So we've got 1/3, and this will be x minus 3, and then the next one will be minus 1/9 times by 2 factorial, times by x minus 3 squared plus, and then we've got the next one there, which is the 2 on 27 one. Okay, you'll probably say, oh, but Mr. Stewart, hang on, that there doesn't look really like what I had before, because it's really not in powers of x. Well, of course, because this is f of x. It's not f of x, 3 plus x. So what I've got to do to finish this, finish off this problem here, and I'm not sure why I've got all that stuff there, but I'll rub off the side here. Let me just see. Hang on. I'll just go here. Let me just rub that off. This looks like from a former problem. So I'll just rub that off there. Let me just finish off really what I need to do here. So I'll grab the blue texter. Now all I've got to do is now find really f of 3 plus x, which will equal to ln 3 plus x, because remember f of x is just equal to ln x, and then all I've got to do is replace x with 3 plus x, and that's where I go like this. Plus that will be x on 3, and then minus, replacing there, that will give me x squared on 18, and then the last term of course will be x cubed on 81. Because if I put here for there and for there, I replace both of those with 3 plus x, I'm going to end up with exactly the same scenario. So yeah, by all means, over here you can use a Maclaurin series, but the question did ask us to use a Taylor series. So that's why on the board the other day I did it like this. I hope that kind of clarifies things and makes things just a little bit clearer. Okay, in the next video, I'll show you how to do question 4, which is almost a little bit similar to this one as well. And I'll catch you then.